So this video is going to go over what it means for a function to be continuous or differentiable. And first, I'm going to explain continuity. So a simple way to think about it is that if you can draw the entire thing or the entire function, the graph of it, without picking up your pencil and having to start from another place, then you can say it's continuous. Like, for example, in this graph, you can draw the entire line of the function without picking up your pencil, just like one continuous stroke. But for the second graph, you would have to stop at, let's say, this point A, and then pick up your pencil, and then continue here and continue drawing. So we can say that in this first graph, it's continuous at all points, and in the second graph, it's continuous at all points, but it's not continuous at x equals a. And a more formal definition that we can use is, let's say you have a function like these two, and f of a equals b, and f of a exists, and the limit as x approaches a from the left of f of x is equal to b, and the limit as x approaches a from the right of f of x is equal to b. So we need to have these three conditions: that at point A, the function is actually equal to b, and the limit from both the left and the right side is equal to b as well. So for example, like we can take this point on this function, f of a is at this point, the limit from the left is this point, and the limit from the right is this point, all the same point, and the point exists, so that means it's continuous at this point. And whoever, at this point A, at the second function, f of a is this point, but the limit from the left side is this point, and the limit from the right side is this point. And since the limits are at different points, not the same value, then you can't say it's continuous at A, but it's continuous at all the other points. So for differentiability, first, assuming the function is f of x, then you need to have an f prime of x, so the derivative has to exist. And let's say at a point A, for a function at point A to be differentiable, then f prime of a has to exist as well. It has to be defined. And the function has to be continuous. So for a function to be differentiable, it needs to be continuous first. And it cannot have any sharp corners or like sharp turns like you see in this one. In this first function, everything's continuous and there's no sharp corners or turns. So that means it's differentiable. And the second one, it is all continuous, but at these 2 points, you have sharp corners due to a modulus function, and that means it's not differentiable. So again, for a function to be differentiable at a point, it has to be continuous at that point, and it cannot be a sharp turn or a corner. And usually, when you just try to differentiate it, if you have the function, just try to find the derivative and try to find the value of the derivative at that point. And if you can't do that, then that means it's probably not differentiable. And now let's do some practice with the definitions that I just explained. So if you think you can explain the continuity and differentiability at the point x equals 3 of this function, then pause the video and try it. But first, we need to find the continuity at x equals 3, because in order for the function to be differentiable, it needs to be continuous. So, as we said, at f of a, assuming a is 3 for our case, it needs to equal a value, and then this case is 2, because at x equals 3, f of 3 is 2. And also, the limit as x approaches 3 from the negative or the left side of f of x needs to equal 2 as well. So from the left side, it's going to be, we're going to be using this function because before x equals 3, when x is less than 3, it uses this function. So that's just from the left side. So x squared minus 2x minus 1 at x equals 3 is 9 minus 6 minus 1, which is 2. So yes, it does equal 2. But also, the limit of x as x approaches 3 from the right side of f of x has to equal 2 as well. And for this one, we're going to be using this one because when x is greater than 3, that's the limit from the right side, so we're going to be using this function. So 3 plus 2 over 2 is 5 over 2, which is not 2. So unfortunately, this is not continuous because the limit as x approaches 3 from the right side of f of x is 5 over 2 and not 2. And since they're not the same, this is not continuous. So it is not continuous. I can write that down. But what about the differentiability? But like I said at the beginning and multiple times before, for a function to be differentiable at a point, it needs to be continuous at that point. And since for this function, it's not continuous at x equals 3, it is not differentiable at x equals 3 either. So it's not continuous nor differentiable. So yeah, that's how you explain the continuity and differentiability of this function. So everything that I explained in this video and the example that I went through should give you the information you need to know about finding the continuity and differentiability of any function. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.